Hello, welcome. Today we are starting a machine learning series where we will predict thyroid cancer using real medical data, and by the end of this series we will build a model with over 95% accuracy. Our data set is gotten from UCI machine learning repository, and it's about differentiated thyroid cancer, which is a common endocrine malignancy, and generally it has good prognosis, but with recurrence it raises concern, and 20 to 30% of patients experience recurrence from cases seen, and early prediction can improve treatment outcomes. Our goal in this video or this series is to build machine learning models to predict recurrence risk and also help clinicians make better informed decisions. Programming environment is Google Colab. You could get it by logging on to colab.research.google.com, and once you get here you click new notebook, and then the space opens up for you to start your coding. We are trying to use a tool that's simple enough for anyone to just code along with no much stress, so you can take out these parts. It's not necessary. Is here. Yeah, so we have a full length page to work with. Let's divide the whole analysis work into different parts or portions. So we are going to import the libraries needed for the analysis, and then always, like we all know, whenever you see hash, it means you want to write a comment. There's data manipulation. Is that correct? Okay, money. All right, and then let me comment that off. Secondly, so to add a new bunch of line of code or a new block of code, you click on this portion. So the first set of packages we install or be importing is the packages for data manipulation. Next we import packages for data visualization, right? Then we're going to also import machine learning libraries. So sorry. We want to import libraries for handling imbalance. Yeah, handling imbalance. So in the course of this coding session, we'll talk about imbalance, at least at a high level. So the data libraries or the libraries for data manipulation we're going to be importing is Pandas and numpy. So just say import Pandas as pd and then import numpy as np. So we've imported this, and to run this code you click on this. All right, so this is the first block of code we are running, and that's why it's taking a bit of time. And then next we're going to import the libraries for visualization. So we have matplotlib, seaborn, and the missingno library. Next. All right, in the course of the coding I will be telling us why we are importing this third library. It's not so popular, but we need it. And then we also need to, let me add a third block here. We need to import pre-processing libraries. So let me see, pre-processing, right? So the libraries for processing we're going to import is the label encoder, the min mass scaler, and basically those two. That's what we're going to be importing. So let's see, from scikit-learn dot pre-processing import label encoder, right? Label encoder, comma, and mean mass scalar. And then for the machine learning from scikit-learn, okay, good. So let's import these. Let's take out this for now. Accuracy score, and then confusion matrix, right? Good. Precision score, sorry, right. All right, I think we're good to go. So these are the libraries we're going to be using for most of the machine learning tasks in terms of splitting data, and then also or evaluating the performance of our AI training. We are going to import the smooth package from Emblem. So like you see, it's already suggested by AI, which is emblem.oversampling import smooth. Yeah. All right, so this is more like all we need right now. So let's run them one after the other. Run this block, run this block, run this block, and run this block. I said this video is about building a machine learning pipeline to predict thyroid cancer recurrence. So you could come here and then get your data set in your local machine or thereabout. You come here and then you drag and drop your data set into this place. This task we're going to do here is to import or to load data set. So let's see. All right, and use this line of code. Say data equals to, first of all, you give the data set a name, PD. So right now we're using this pandas we already imported there, and make sure you run your pandas block of code before you do this. Read underscore CSV and then open bracket, then we say thyroid dot cs, right, CSV. So let's load this in. Sorry, that was a mistake. Thyroid diff, and then so our data is all set. Let's take this out. All right, so to see what we just loaded in, to see if it's properly displayed, imported, so let's say display first few rows of data, first few rows data set. Simply just type print data dot add and then put your parentheses in front. So you could see we're able to print the first 5 rows of our data set, and you know Python is 0 index, so we start from 0. So 0 is the first row, row 1, row 2, row 3, row 5, and then yeah. So if you were to count the number of columns, you see we have about 17 columns or thereabout, and then that's it. So for us to properly know the nature of data set, we have to get information about data set. So let's say get data set info, just to explore the kind of data we have. We want to print this, print data so you see it gives us a rundown of the kind of data we have. It says there are a total of 383 patients in our study, because each of these rows, we can also do another set of checks on this data by doing more like summary statistics. So summary statistics. So here print let me say print data dot describe, and yeah, so let's print it and see. So this is what is printed, and something else we could do to transform this, put dot t here just after the parenthesis for the describe, and then print it. So this one is showing us more like for the count, age, the mean of age, the standard deviation, and all of that. If you notice, if all of the data are on strings, right? The only data here that is on numerical type is the age, and that is why it gives us this summary statistics of only the age related data. And then right now let's do let's check if there are missing values, because you are not going to train an algorithm with missing values. It's very important that you check for missing values, and this is how you're going to do this. Check missingness. Let's say check missingness. So let's print. So this is what you do. So you want to take the sum of all the missing, so there are no missing values, and we don't get to be worried about how to fill in those blank spaces, right? And then I want to introduce something to us. This might be a bit should I say a bit advanced? Not really advanced, but let's just digress from the basic stuff, and then let's try to use a color scheme for most of our visualizations going forward. Stuff to do is to assign our colors. So we say colors equals, make a list of the colors we want to use. So I saw this very beautiful color scheme I like to use. I think I also saw it on Cargo, and then I give my interpretation of this color scheme. So we could say color scheme CNS dot color palette so let's load this in. All right, so we already have our color scheme saved up. So to visualize this, let's see what we can do about the visualization for this. All right, so to visualize color scheme, visualize color, yeah, let me just say colors. We could do CNS, which is the seaborn package. Use this plot, color scheme, and then use a very small size. Then use here, we're going to use a matplotlib. So let me do this at minus. So let's get in the metadata for our plots. Let's use a font of serif, and then size of fonts 18, and then let's make the weight bold. All right, what other thing can I do? Okay, let's set the opacity for an alpha of 0.8. yeah, 0.8. Okay, then let's show the plot the show using matplotlib. Okay, hopefully everything is set correctly. All right, so let's run it. So this is the color scheme we're going to be using for our plots. All right, then now let's do something interesting. I want us to plot to visualize the missing values. You know, first of all, I said there were no missing values, but what if we had the missing values? How do we visualize it? So let's say color equals color scheme. All right, it's more like we are reassigning values or thereabouts. Did we? Color. Okay, we've not assigned color, right? All right, so we can go ahead and then assign the figures we're going to be plotting, but now let's do a subplot. Subplot is more like having a big plot containing smaller plots, and you set the size for these plots. Use a 12 by 4 size. Sorry, I suppose use 12, not A. And then set the resolution for the plots. We use a resolution of 70, and then assign the patch face color. Let's set face color. Let's use this color. Sorry, I'm putting in parentheses. Sorry, F6, F5, F5. Very easy to remember. F6, F5. Then for the second plot, set face color also to the same. Right now, so let's bring in, if you remember, the one of the modules that was imported. Where is it? Which is this? Right, remember? So we're going to be using it to plot for, yeah, we're going to use it to plot the missing values, but we are doing a bar chart for now, and the data set is what we've named as data. So we are going to be checking or visualizing the missing values in the data set, and the name of our data set is data, and the color scheme we're using is the color scheme called color, right, as defined here already. And then we set font size to 8, right? So we could decide to take off labels. Should we take off? Yeah, let's just take off labels. So the labels could be off, and then filter should be shown at the top, right? I believe this is correct. No errors, no syntax errors for now. So let's see if this could be plotted. All right, so we have this here. Okay, let me see. We name this font size nothing like this. What else could we have done wrong? We didn't properly spell out font size. So good. So we see we have a very nice plot here trying to see how many of our data is how many of our how many rows in the data set is having any missing value, and we can see that every one of them has got 383 observations, so there are no missing values. Let's forget about the colors. I think this is a bit unprofessional, but it was just nice visualizing something very colorful, right? All right, on a very good day in your analysis on your future work, you could implement the code base or these lines of code to do something much more meaningful using the same pattern also. And you see how we're able to say, well, we wanted to sort the visualization from descending in a descending order. So if there were like multiple missing values, it would have started from the observation or the variable with the most missing values to the one having the least missing values. All right, so what else can we do here? Okay, we could also decide to properly label this figure, because in data analysis or data science we always like to annotate our graphs, our visualizations, right? So let's see, to visualize this, to properly annotate this, let's use this. Okay, so let's give the name visualization of the nullity of dynamic and error. Okay, and then just at the end of this with a comma here, and then set metadata, which is like the fonts and the rest. So for here I will say fonts. I always like using serif. And then the size, let's use somewhat for the big size. Sorry, it's not a string, so 24. And then color, parenthesis still. What color should we use? Let's say black. I'm typing faster than my head. Then alpha 0.8. Okay, then let's go to some other labels that we could use. Test, let's place this somewhere else in the plot. -1, 1.2, this is more like just annotating our sorry about that, this is just annotating our data a bit more. Overall they are like 383, right? Data points present right. And then let's copy this. Should we copy this completely? Yep, let's copy this. Then maybe let's reduce these to 12. So okay, let's do 0.9 here and then 0.7. okay, so any more stuff? What can I put here again? So you see, at least we have some level of visual hierarchy as well as the name for our data set, or for a title. Yeah, we have a title for the visualization. All right, and then one more thing we could do is to check if there are duplicates in the data set. So we want to check for duplicates. So these are all steps in data processing. Duplicate checks. You don't want to train your model with data that's been duplicated. It's going to introduce some level of bias, or maybe even overfitting into the system. Number of duplicate rows. So to do this, run this code. Let's say dup, right, equal to data, right, dot duplicates, sorry, duplicated, and then close parenthesis, then let's sum it up to get the total number, right? So I could just print dup here. This is much better. So you see we have 19 duplicated rows, and the next step is to drop these 19 duplicated rows. Okay, data, right? So right now I want to reassign this name data, so that from now on, by the time we refer to this variable called data, we are going to be referring to the new version of data, not this one. But we could also rename it, so to avoid misplacing the names in the future. We could say, okay, plain data. Let me see, data without dup. Yeah, data without dup, right? Sorry, data without dup. Wow, it doesn't sound nice. Data without dup. Okay, I could see data without dup is equal to, right, data, right? Good, let's do this. So right now, whenever I want to refer to this, we could use this, but now we want to rename our data as, all right, good, this is much better. I hope that is not confusing. You could scrap that for that part in case it's confusing to you. So we are dropping duplicates, right? And then if you want to drop duplicates, this is the code you use. So let me say create a variable to hold the original data set, right? And now remove all duplicate data. All right, so now create this, do this, and then if we were to visualize this again, let's visualize. Sorry, not visualize, display data after row, after duplicate drops. So here now, let's do this. Data. So let's print. Print. So as you can see, we now have 364 entries because we're able to drop our 36 duplicate data. Alright, thank you very much for staying put. Next video we are going to be doing so much more exploratory data analysis, where we will dive deep into gender distribution and recurrence, smoking patterns, cancer staging, and risk factors. We will be creating very beautiful and very insightful visualizations to see patterns in data, and this will help us in the modeling phase beyond that. Alright, so if you like this video and you are looking forward to the next, please subscribe and hit the bell for notifications. Also download the dataset from the link in the description and try to replicate what we did today. You can also drop your questions in the comment section. See you in the next video.